My name is Stefan. I'm the co-lead of API banking at Deutsche Bank. Today, I'm joined by my colleague, Timothy Goodwill, hopefully. And we will be walking you through how we built an AI-ready API ecosystem. To start off, let's go through some scenarios, some use cases, how AI is currently being used in finance. And these are general examples. It's not how Deutsche Bank is using this necessarily. On the one hand, the first I'd like to walk you through is real-time fraud detection. You may know this from your credit card transactions, when maybe your credit card is stolen or cloned. The financial institutes, what they are doing is they are ingesting in real time financial transactions, payments, or card authorizations into machine learning models to identify whether this transaction is unusual for that specific client, preventing financial loss for the client as well as the bank. The second use case is the automated cash flow forecasting. Financial institutes offer to their corporate clients cash flow forecasts. What they do is they mix multiple data sources, being it the ERP system of the client or maybe an Excel file, historical transactions, and they will forecast the future incoming and outgoing cash flow for that specific client. And they are now using AI for this, and already AI is overperforming the forecasts performed by human beings. The third one we probably got across already. I think in the past, many of them were not really AI-based, but a simple search response type of thing. They're using this for customers inquiry. We see this use case in Europe, and we see this use case also in the US and probably other regions as well. They maybe it's only for question and answer, but there are also some more advanced use cases where the client can actually via chat trigger a payment or inquire account statement. The last example we have here is the overnight portfolio rebalancing, more on the robo-advisor part of things, where AI will scan the client's portfolio on a regular basis, and based on the risk profile and what is the portfolio at the moment, the AI will make proposals how the portfolio for that specific client should be changed or could be changed to meet the risk profile. In Deutsche Bank, what we have is one of the uses is the next best offer project, where algorithms are analyzing the customer portfolios and providing product suggestions, as we may know from Amazon, for example. It's providing validation for the client, for example, to sell a specific asset in case that client is overly exposed, possibly in a specific region or something. We have been declared this year is the year of agentic AI, and to underline this, we have heard a little bit about it, but it sounds like it's been there for. It's only since November 2024 when the Model Context Protocol was announced, and also just this year, a few months ago, the agent-to-agent protocol. Those two protocols are to revolutionize how we are interacting with AI in future, and we would like to deep dive further into this. That's the moment where my colleague Tim comes, but he's not there yet, right, Rebecca, Laura? Nope. Okay, I will keep going. So I'll try to fill this gap here a little bit until we have Tim with us. The Model Context Protocol and to agent protocol, they are they are complementary. So what the model context protocol, MCP, is trying to do is to allow AI to in-source new data into their model via APIs, file systems, or databases. Agent to agent is try to connect different agents with each other. We have seen in previous presentations agents talking to each other. One of the solutions how this could happen in future or right now already is via A2A. So even Google, who has announced this just 2 months ago, they are claiming that this is not an overlap, this is not a replacement of MCP, this is a complementary feature that they are offering. For today's presentation, we'll be focusing more on MCP, and I'm happy that Tim has made it. I can see Tim has made it. Tim, can you open your camera, open your chat?
Yes, so Tim, if you can hear me, turn on your camera and that will bring you onto the stage. Today is the day of the from this.
So I will try to keep going. Unfortunately, I will not be able to do justice to what Tim would add to this presentation, but I want to bridge this time and allow us to, I mean, we are so on track. I don't want to overrun too much. Now, or the MCP are bringing some benefits. Tim is back. MCP is bringing benefits, but there are some risks. So the thing is that with MCP, with agents interacting with AI, this whole thing may go in a direction that today we simply cannot predict. Also, security vulnerabilities have been identified with MCP. One of the big things that you read on the internet today is that MCP is just not as secure. Now they have just announced, I think a couple of weeks ago, somebody else joined me. Tim has joined me.
I have.
Tim, can you save me
Yeah.
over from the risk and opportunities?
I'll run through this. So
Thank
MCP
you.
shows a lot of promise, and it's going to open up a lot of opportunities, but there's also a lot of unforeseen risks. And so a number of security vulnerabilities have been found, and we can read about those, tool poisoning, rug pulls as an example. And more will emerge, never-ending sort of competition between hackers and some security governance. At the moment, MCP gateway and registry concepts are immature. So we have OAuth 2.1 now built into the protocol, which is a really good move, but how are we going to govern it? At the moment, MCP gateway concepts are sort of being hashed out. Are we going to manage it as a reverse proxy like a REST API gateway? It has limitations because JSON RPC 2 schema is very lean. It's a do anything schema. We invoke methods, we pass parameters. We don't really know what's going on, and so it's difficult to sort of apply that governance at runtime. Alternatively, we could set up an MCP gateway as a fully fledged MCP server, which is brokering tools and resources from upstream MCP servers. But what are the overheads? How does it scale? What are the security patterns that should apply? So there's a lot to be worked out in this space. So I've read quite a bit about how MCP is sort of microservices based. It's going to save us from sort of monolithic APIs, which is just not true. I mean, REST architectural style is built around microservices, managing resources and sort of securing them at a granular level. And if you're not doing this with APIs now, there's no reason to believe that those building MCP servers are going to do any different. So the thing is, how can we secure MCP, especially in large, complex organizations? and those that sort of are very concerned about security, do we have the sort of, I don't know, 5 or even more years it's going to take for these best practices and frameworks to emerge? I mean, it took nearly a decade for us to nail REST. The thing is, though, we have a ready-built governance stack for REST. And for instance, we understand OWASP top 10 security risks. It's well governed, maintained, it's well known, it's auditable. We know how to implement the security tactics. We know how to integrate with IDPs and consent services. We understand security patterns. We can provide the information that to API owners that they need in order to approve access and at a granular level. API version management is governed. Everybody understands it. And we understand, importantly, really important, we understand how to apply policy to controls and how to enforce them. We have visibility of the ecosystem, and in some cases, in many cases, hopefully, we have active threat protection, that's SIEM and SOAR, in order to, so we can sort of actively and dynamically respond to threats in the environment. So, in the meantime, we all hope, I don't want to be a wet blanket, we all hope that MCP will mature and become a robust framework, but at this point in time, the way to expose and protect your business capabilities is to back end your MCP services with your existing strong API governance mechanisms. Now, next slide, please, Stefan. So I won't go into this slide in great detail, but again, REST, microservices, self-service, and decoupling, and the way we achieve this is designed for composability. So we build stable, genericized interfaces to our business resources. We don't need to anticipate every possible use case. We align our resource APIs with our business domain. So our focus should be on developer experience over client centricity, because in the end, our APIs, they represent the business facts about our business domains and a standardized interface to our capabilities. And we don't need to overload our APIs with assumptions about how they're going to be used, especially in AI use cases. We want to open up new possibilities. Document for clarity. Remember, our documents are this is the way we communicate what our API is doing to our devs, but also to AI systems. So there's a list there. Always define schemas. Describe everything, define security at a granular level. Next slide, please. So how do we apply governance? First of all, we need tighter API data model governance. Many of us have been pushing this for years, but it's not always in practice. But what we need now more than ever is a stronger model governance. We need to classify our data. We need to define the domain semantics. We need to understand the lineage. Like, is this data mine? Should I be sharing it? We need to be able to implement limitation and minimization as per GDPR requirements. We also need to take care of other things which are not necessarily regulatory, but we need to understand how to make our APIs faster and more composable. Like, for instance, read models that are implemented with CQRS. We have granular security applied. So we need to have a design practice. We need to ensure that our models have some oversight before they're actually implemented. So again, granular access scopes, fine grain, time limited access, and we need to define scopes, security API scopes at a granular level, so that we can apply appropriate security to the models that we're exposing. And if you have not implemented OAuth 2.1 and RFC 8707, that's resource indicators. That gives us the ability to constrain our tokens to a particular resource context, and that's really important. So ask for a roadmap if this is not in your organization already. Again, documentation, really important, but it needs to be derived from validated models. So we need to understand the data that we're sharing. It should model a single aggregate or subdomain. We should understand the semantics, make it very clear, classify our data, and again, apply scopes. Next slide, please. Okay, so how do we do this? Domain-driven design. So we all understand the importance of domain-driven design, but I guess it seems too difficult. It seems overwhelming at times, but we don't need to think of it that way. Mostly what we need to do, we need to start with identifying our stakeholders. We need to get our domain experts in the room, people that understand the business domain, and conduct workshops and sort of together share ideas and our knowledge of the domain. One of the ways we can do this is with event storming. It's a fairly lightweight but well-structured way to run workshops to make sure that everybody collaborates, everybody is invested in the process. And those the data models that we learn about the domain. We need to capture those. We need to capture vocabulary and the aggregates and the entities, and we need to validate those. Go back to your business stakeholders, and go back to the other stakeholders like your security architects, your data architects, to make sure that you're appropriately modeling and appropriately sharing the data in your domain. So and we can generate API specifications directly from the model. And again, it will need some technical validation. And of course, we can use open API tools to generate scaffolds, mock servers, test collections. So yeah, without going too deeply into that, it's something that you'll need to design for your own organization, but it's all about visibility and governance at the right time. Okay, Stefan, over to you. Microphone, Stefan.
Stefan, you're muted.
I'm talking on my own. Thank you, Laura. Can you hear me now?
Yes.
All right. A few more slides to go. Sorry for the delay. Real quick here. We have learned how to design APIs, but where are APIs exactly being used? We talked about this in previous sessions, so I won't focus too much on this. But obviously, for model training, you want a standard integration to your model. If you're a data provider, you want to be able to monetize your data. This you can do via APIs. Once you have trained your model, once you have your model ready, you want to expose the model. You also do this via APIs. And in the agent area, everything happens via API. That's where the magic happens. In a chatbot, you not only receive question and answer, you can actually trigger a payment if you're a bank, or apply this example to any other type of organization via the chat. That's where the magic really happens. Now, if APIs are so good, we actually see that APIs initially, or if not well managed, they're actually creating a problem. If you have a monolith, you have all your interactions within the same application. So we have this piece of code talking to this piece of code, exchanging data. And if you break this all down into APIs, you're creating a fragmented landscape, which is leading to a complex integration between the systems. One system may be hosted on cloud, the on-prem. You need to find them. You need to establish a new connectivity. Different applications may have different security standards. You are losing visibility if you are queuing in a workflow multiple API calls and something fails. You suddenly don't know anymore where this is failing within your own organization, because all increasing your maintenance costs. This is where API platforms, which we see as a key thing for your API journey as an organization, but also your AI journey. The API platform solves this problem because suddenly you have a unified and transparent ecosystem. Everybody's connecting to the same host. So no, people are not connecting to multiple APIs anymore. Everybody's connecting to the API platform. The API platform is rerouting traffic. So you have a rapid delivery. You have centralized security, full transparency, and this is all obviously reducing the maintenance and complexity costs. Now, that's a slide I wanted to focus a little bit on. The API platforms are also going to be very important for your AI strategy. Tim has security, and built-in API platforms offer security features for you to manage with subscription comparing to API, which scope they have, what they can see. You can opt to use OAuth 2, or maybe if you are willing to else, you can use MTLS, for example. You have API platform offer a decoupling layer. So the AI is only going to connect to the API platform. What happens behind the scenes is up to the API provider. So if you change something in the API implementation, if you rehost your API implementation, the consumer doesn't have to change anything. Throttling and rate limits. You cannot control what AI is doing. So AI may be calling your API many, many times. And this would increase if your API is running on the cloud, for example, or maybe this is overloading your API. An API platform will help you addressing this. And also with response caching, the API platform can cache the response. So if AI is calling, asking who's Stefan again and again and again, this is being cached and it's not going to your API any longer. And you have load balancer. So AI wants to have stable connectivity to the APIs. And with an API platform, you have built-in load balancing capabilities to fail over if a server is down. You can also enforce these standards that everybody has been talking about today. Tim has talked about deeply about this today as well. With an API platform, you have a centralized catalog. You can see every API that you have, and possibly you can also see in future your MCP tools, and you have analytics and monitoring. So you can see what is happening, who's consuming your API, which is this agent that is consuming your API too much, and everything. And we see similar challenges for MCP servers. Centralized documentation, catalog of the MCP servers, standardized schemas and versioning, security. We talked a lot about security today, and monitoring the usage of the MCP servers. So I would like to end this talk with the question: if we are facing similar challenges, can we apply the same best practices to both MCP and APIs? Thank you very much.